All right, so week 4, we are going to cover joints, and we're going to be kind of hitting basics right now. So some of this may be some review if you've taken a previous course, but really we're going to kind of hopefully take it up just a little bit of a notch. We're going to query multiple tables, and then we're going to cover a couple kind of scenarios where things may kind of be circular, do duplicate versions of the same table, um, those kinds of things. So I think we all, um, the concepts of joins aren't too hard, but what I like to always do is start with kind of like a history lesson. So there's two versions of SQL. There's the ANSI 89 syntax, which came out first, and then there was the ANSI 92 syntax, which we're still using today, as far as joins go. So I like to cover both of those because I feel like the ANSI 89 version, which was a little bit more manual, kind of helps us kind of like get the picture a little bit before, and then when we do the 92 version, it becomes a little easier. So that being said, I'm just going to start with a really basic join. So I'm going to take a look here at Sequila, and I'm just going to find a real simple kind of join. So what I'm going to do is I'm going to look at the rental table. So let's use Sequila, and then let's select everything from rental. Sorry,
Is the screen blurry for other people, or is it just my eyes?
It's blurry for me as well.
Is it? Okay, let's
Yeah, me too.
let's see if we can fix that.
But I totally get the thinking, is that just my eyes? So I get you.
Let me try to reshare and we'll see if that works. Stop 2 and let's try again. Is that any better?
Much better.
Much better, thanks.
Yes.
Perfect. Yep, awesome. All right. Perfect. So I'm going to select everything from rental, and we're just going to take a look in here. I always like to kind of like poke around. So when we're joining, I like to think of, because as we know, when we join things, kind of like we talked about when we did our reverse engineering, when we kind of designed a database, the primary key connects to a foreign key, and we kind of connect typically. I mean, technically we can join on anything, but typically that's how we define a connection, a relationship that we can join on. So in this case, we can kind of look here and see a little bit of information. And right now we can see this customer ID. Well, we have a rental ID. We know, since it's the first column, typically that's the primary key. We could actually look to see the primary key, but we've been in this enough, we can kind of assume. And then we can see an inventory ID, a customer ID, and a staff ID, along with just generic rental information. But for right now, we're just going to focus on this customer ID, and we want to say, hey, because there's customer ID, I know that there's a way I can connect rental and customer. So we can say that, if we wanted to see every rental and the customer, or let's say every customer and their rentals, we could do so. So we're going to start by doing select, and I'm going to make a comment here. So we just keep note here. This is the ANSI 89 syntax. So to start off, what I always like to do is start with my base data. So I'm going to select everything from customer up here, and then we'll add it. Customer. So really all I care about is probably the customer ID. So I'm going to select the customer ID and the first name and the last name. And let's do email. So from customer. So now I can run this, and there it is. Now, we know that customer ID, when we do our join to rental, is going to exist twice. So one of the things that we can do is we can create what's called an alias. And an alias is basically like putting a table name in front of it. So to put it longhand, I can say customer ID and do that. But we'd have to put we could put customer in front of all this. But that gets cumbersome because we always try to save keystrokes so we can be quicker. So a lot of times what people do is they'll just use the first letter of the table. And so in this case, we're just going to use C. So I'm going to do C dot customer ID, C dot first name, C dot last name, and C dot email. So basically, once we do this space and then C after the table name, it refers to customer as C. So we can just put C as the table. So customer dot and then the column name. So we can run this and it works the exact same. Now what we're going to do is we're going to do what's called a join. And in ANSI 89 syntax, what we do is we take every rental and we combine it with every customer, right? So this is called a cross join, which we'll cover later. But what it does is it generates something that you'll see referred to as the Cartesian product, which is basically customer records times rental records, meaning if there's 599 customer records and there's 1,000 rental records, if we pull out our handy dandy calculator, we can say, okay, 599 times 1,000, we're going to generate 599,000 records as a result of this join, which is quite a bit, right? So basically, just like as if we had two dice and we wanted to, see every possible combination, we figure out every possible combination. That's what a Cartesian product is. That's what we do with a cross join, and that's what ANSI 89 syntax is. So what we do is we say join and we say rental R, right? And we don't specify anything after that. We just say rental R, and I could run this and you'll notice that it's going to generate, in this case, just 1,000 rows, but let's add in r.rental ID. And it might be joining automatically. So MySQL will join automatically, but let's just throw in a cross join here. Or what we can do is we'll do this. Let's just change this to a comma.
I think it limits it to 1,000 by default.
Oh, does
That's why
it?
you're not
Yeah,
getting
maybe.
more. Yeah.
Got it. Okay, well, let's do this. I'm going to pop open our handy dandy command prompt. And we're just going to do this. All right, and I'm just going to take this and pop it in here. There we go. So as you can see, this isn't super efficient, but it generates every possible combination and it's going to print it out. So all 599,000 records, according to our math. I'm going to just kill this because we can fix it. But so what we're going to do now instead, because there's probably more rentals, because if it limits it to 1,000, we're probably way beyond that. So if we really wanted to see, we could select the count of everything from rental. So really it would have been 16,000. So really we would have ended up with 599 times 16,000.
I think it said on the bottom when you killed it, it said retrieved or something.
Yeah, 9,061,000. Yeah, so and we could do a count on that, but basically we, in the ANSI 89 syntax, we just do a comma that signifies a join, and then we typically what they did is we wanted to filter it down to where it actually means something, right? So we generated every possible outcome, right? So people who didn't rent that movie, we still match them up, which isn't correct. So what they would do is then they'd filter it down. So then we'd say, oh, we only want to see it where the customer ID from both these match. Because if we look back on our two tables, we know that obviously customer ID has a customer ID, or customer has a customer ID, but rental also has a customer ID. So we only want to see for each customer the rentals that they match on. So then we just say, hey, I only want to see it where c.customer ID, customer.customer ID is equal to r.customer ID. And this one should give us a lot better results. So still just limiting the 1,000. We can actually, let's just copy this real quick. Select the count of everything, and we can see 16,044, which is exactly the number of rentals that we had, which is right. Because basically we're taking all their rentals and attaching customer information. So now we can kind of see all the movies that people rented in list form. So Mary Smith, rented these ones, and we could go through and check these. So there it is. And you can see that because there's more, because of the relationship rental to customer, customer is a one-to-many relationship to rental because a single customer can have multiple rentals. That's why we see the customer information duplicated once for each rental that they're assigned. So anyways, that's the ANSI 89 syntax. So basically, I like to show this because, if you think about it, like if we were trying to match, like let's say we had folders for each student in, let's say we're an elementary teacher and we have a folder for each student that we're going to put all their projects in from the term for parent teacher conferences. So we have, one folder for every student, but then we have many assignments, one per each student. And so basically we need to, put them in the right thing. So we might go through the entire pile and do it. Now in that case, like we only have one copy, so we're not going to duplicate it. But when it comes to our data, basically we do that so then we can filter it, right? So we say, give me every possible combination and then filter it down based on the criteria where they match. Now, the problem with this is, as you saw, we generated a lot of data. I mean, you could see it was still trying to print it all out. It takes up RAM. So when we do this, it's taking up RAM on our server, and because it has to generate all that data and then filter it. That's why in week 1 or 2, no, week 2, we talked about the order of operations. So the first thing that the database does is it generates the data and next it filters it. So that's why this is important, is because when we first do it this way back in the day, it would take all this data, build every possible outcome, and then filter it, which, in this case, I mean, you saw how slow it was just for us. You can imagine in massive databases like Amazon or similar, how costly that would be. So then they came out with a new method in ANSI 92. And they introduced new keywords called join, left join, right join, and cross join. So essentially, to get the same outcome, all we would do is, instead of having this comma here, we would say left join. And basically, the left join means that we're taking everything from the left and matching it if it has a match on the right. So we're going to include every customer, whether or not they have a rental. And there's a nice resource. If you just Google SQL joins and then do an image search on Google, it'll pull up all these. This is my favorite little image here. In fact, when I do when I took my SQL certification exams, I always would draw it out just like this. So in this case, we're doing a left join, right? So customers A, and the left and right, they do the exact same thing. It's just a matter of order. Which one's listed first versus second? So in this
So
case,
is the one listed first left and the one listed second right?
correct. Yep.
Okay.
Yep, exactly. So in this case, customers A, because we listed it first, and then rental is B. So according to this, if we look at this, so we're going to get every customer, whether or not they've had a rental, because if they, if they hadn't had a rental, that would be over here. And so, you can kind of use this to because we all know how Venn diagrams work. So, so this includes customers, even if they don't have a rental. And this is important because when you perform queries, when you write these queries, it's important to know how or what the outcome is. Because there may be times that we say, hey, we only want to see customers who have a rental. So it's important to know like the logic, and we'll talk more about that. But for right now, let's just we can kind of just know that it's left and right and what it does. So in this case, we're getting all the customers, and obviously there can't be a rental without a customer. So so in this case, these don't matter anyway. So we just do a left join and we're going to join them up. But the difference is, instead of having a where clause, this clause is built into the join. So in the actual programming of MySQL or whichever database you're using, it's built into where it gathers the data, it filters it ad hoc. So instead of it generating this mass pile of data and then filtering it, it kind of does it along the way. And so this is largely more efficient, but it requires this on clause. And basically it works the same way. You just choose, hey, I want it to join where this equals this, and you can match them. And you can do any conditional logic here. So greater than, less than, some of those weird cases, but we're going to ignore that for now and just focus on joining these tables where they're designed to match up, because technically you can join on anything, but that is not great data design. And I mean, we use it often for like ad hoc analysis type stuff, but largely for designing a database and developing for one, it's going to be set up like this. So we can run this, same result. But you'll notice, even to gather the 1,000 records, it was faster. I mean, and we're talking minuscule things, but you can see that, it was faster. So anyways, that's ANSI 92. Now, let's look here for a minute. Let's take this to the next level, because that's two tables, right? Now, if we want to take this one step further, we can look at, let's select everything from the inventory table. And we can see in here, we have an inventory and we have a film. And so let's say that ultimately what we're trying to do is see what film they rented in this report. So we know that rental had inventory ID. So then we look at inventory, and inventory doesn't have the name of the film, but it has this film ID. So if we look at film, we can say, oh, there's the data I'm looking for. So a lot of this is like, I almost think about it as like, those like dungeon crawlers back in the day where you'd like go into a room and there's only so many like exits from there, and like it goes from like node to node. I kind of think of this like that, where where you want to get, and so you have to kind of like find the path to get there. And that's essentially what we're going to do. So we're going to next join to inventory, even though we don't need anything from inventory necessarily. That's kind of how it was designed, so we got to get there. So we're going to next join to inventory, again with a left join, because here's what's interesting. So from this left join, the left isn't rental, it's what we already got from customer and rental. So as soon as you finish a join, so basically after the on clause, this all becomes and acts as like one cohesive table, because we've already joined them. So now on the inventory side, we have to do a left join because we want all the customers and all the rentals combined, essentially. So when you do these, just know that it doesn't apply to whichever table came previous. It applies to all the tables and the resulting join. So whatever we selected, that is now considered the left side. It's just in memory. So we left join, and this time we're going to do it from the rental.inventory ID equal to I.inventory ID. Now, again, I'm going to just select this. We should get the same pretty much result set. And we just kind of had to do that to kind of get there. If we really want to kind of like troubleshoot, we can add inventory ID here. And then that way we can kind of see how this is working. So there's all of our inventory IDs. And then finally, we want to go from there, and we're going to left join again on film on I.film ID equals F.film ID. And now we're going to add the film ID. And we're going to add the title. And now we can see, you know, the customer information, the rental, and what film it was. All right. So there's a left join. Now, we're going to do one more little example here before we cut over to the exercises where we can walk through.
You have a towel?
So
Go get a towel, please.
I'm going to select everything from the, let's use the film and film actor tables. So basically we're going to use film and film actor to kind of show a little bit of the left and right thing just a little bit. So I'm going to start off by selecting everything from actor. Okay, so we want the actor name, or first name, I guess, A dot first name and A dot last name from actor A. And I'm going to left join film actor A on A dot actor ID is equal to FA dot actor ID. So basically this is how we're going to get to what films a person was in, an actor. And then I'm going to left join that against film on FA dot film ID is equal to F dot film ID. So we're going to have the first name, last name, and F dot title. All right, so here we can see all the actors, and because we're doing a left join, we should get all the actors, whether or not they were in a movie. Now, it looks like we don't have any that weren't in a movie, so what I'm going to do real quick is add one. So I'm going to do a quick little insert. And I'm going to insert one quick. And I'm just going to put, I always like to pick on Bilbo Baggins. Oh, I guess we need Bilbo here.
You should do that shortcut again when you're done with this.
Yes. All right, so I'm just going to insert that. There we go. Now, and good question how I got there. So the one nice feature of this is if you right click on the table that you want to affect, you can go to this copy to clipboard, and it has a bunch of different things. It has like select all statement, an insert statement, update, delete, create. So you can kind of get all the stuff. In fact, whenever I'm like taking a look at some of the data, I and like want to see what a table's definition is, a lot of times I'll just copy the create statement so then I can see exactly what was used to create it, and how it's set up, essentially, or basically how to recreate it. So that way I could say like, oh, last name can't be null or something like that. And I can also see that the last update date has a default of current timestamp. So technically, if I wanted to, I could just delete this and it will put it in there for me, which is what I'm going to do. So anyways, that's a nice little trick. Save some keystrokes as well. So anyways, I inserted this actor, Bilbo Baggins. So now, because we inserted an actor, but we didn't put anything in film actor, he's not in any movies. So now if we take a look here and scroll clear down to the bottom, or I guess depending on how we have it ordered, let's say order by a.last name. Let's look for Baggins. And there he is. So you can see Bilbo Baggins is not included. Now, if I were to change this to an inner join, or he is included, but it just had null. Now, if we were to come down here, you'll notice that he is not there. And that's because he doesn't have a record in film actor. And because we did that inner join, we're only going to get the ones with matches. So that's why it's important to know, oh, are we only wanting to get a list of people in movies, or do we just want to see all the actors, whether or not they've been in a movie yet or not? All right, so let's change this back to a left join. Now, the other thing I wanted to do is take a look at if we wanted to flip this and say, hey, what if we want films that don't have an actor in them? So rather than have to like rewrite this, that's why they gave us this nice little thing where we can just say right join. So what we're going to do is we're going to say right join and right join, because now what we're doing is essentially we flipped this whole thing upside down, because really, because it goes right, we're going to get everything on the right. So we're starting with actor, but we only care about what's in film actor. So if there's not an actor in there that's in film, we're going to exclude it, right? But then down the chain, when we go to this, we're going to get films even if they don't have an actor in them. So we're going to keep it ordered by film.last name. Let's see if there are any to start off with. And sure enough, there are. And this could be something like a documentary, something like that, where there's no actors. So you can see here that we are getting all the films, whether or not they have an actor. It's like you can see here that we have, our ones. So now, what if we want all of them? Let's say, because we did one that had the actors, but that would exclude the films that didn't have an actor. Because before we were, actor was A, film was B, essentially, and we were excluding any films that didn't have an actor. Then we swapped it to a right join, so we got all the films, but none of the actors. So Bilbo Baggins wouldn't be in this latest query. So what if we wanted everything? And that's called a full outer join. And I think we may be jumping ahead here a little bit, but it's fine. I'm gonna say full outer and full outer. Now, MySQL really doesn't like full outer. So basically what we do instead is we just say join. And I don't believe that this will get us all the way there, because join,
I think you have to do a union all.
you could, yeah. So MySQL doesn't support the full outer. I don't believe.
I don't think that's the union all. I think what we did last class instead.
Yep. Yeah. Okay. So it doesn't support the full outer. And so basically what we have to do is find basically find one and then the other. But we're gonna I think we are getting a little bit hex. We'll come back to we do unions in another week. So we'll come back to this. But just so you know, it is possible, especially with other database systems. And I guess this is maybe a good time to reiterate the fact that MySQL is a great free product. It's used widely, but it does have some limitations. And sadly, this is just because it's free and open source, but it's maintained by Oracle, which also has a paid Oracle database. And so obviously they probably don't want their free version to be as feature rich as their paid version. So some of those things are excluded. But anyways, but in a lot of other database systems, because the nice thing is from this class, you'll learn SQL and you can apply it to any of them, any of the database systems. And, with most of the things are identical. A couple of the functions get a little different, but, easy enough to learn those on the fly. So if after this class you want to apply to jobs with your newfound experience, just know that you can pretty much work with any of them as far as like a writing SQL standpoint. All right.
Just quick question out of curiosity. When you did your aliases, you just did space alias, which I understand works. Is that common instead of writing the word AS behind it? To me, it's just being explicit. Makes it a little easier to read.
Yeah, some will let you do that and others won't. Almost everywhere I see it, you just do the space. I think
Yeah.
not every
I
system
noticed.
supports this.
Yeah. Okay. I didn't know if it was like to save keystrokes or what, but
Yeah, mostly for me, that's what it is. It's just simply to save it. Because a lot of people will put this like on the same line. Like this. I like to kind of separate them out just for that reason, just to kind of make it a little bit more readable.
yeah, just cracks me up. Some people like inner join. They specify inner join, but then they just do the space for it. So like specify some stuff and don't on others. So it's inconsistent. And like SQL
Yes.
Assistant, you can do SEL instead of select, so they'll save 3 characters there, but then not do it over there. So it's just, I don't know, it's just funny. But
Yeah.
people pick and choose to save characters on.
Yep. Yeah, and so I don't write as just because it's, to me it's like implied, but I always use an on clause like without fail, because I mean you can do a couple other things. So like if we come back to or do we have a simple one here? Yeah. So like if we wanted to take this ANSI 92 syntax of this one, which we just did. Say left join. Changes to on. So because this is both using customer ID, MySQL actually can infer sometimes, but there's also this using clause where if they have the same name, you can do it like this. And I really don't like this method because that way, if you ever want to change it, you have to basically rework it. Or if for whatever reason someone changes a column name, it messes it up, which the other way would too. But just to your point, it's just a little bit more clear than just like this using. So I'm a firm advocate of just always list out your on clause. Good questions. All right. So what we're going to do now is we're just going to take a look through some of these exercises and just kind of talk through them, make sure they're clear. So this first one basically says, fill in the 1 and the 2. So you can just put like 1 equals this, 2 equals this, which like we just said, it shouldn't be too crazy. So in this case, it's just asking for the alias, and we can see the aliases around. So that one should be fairly simple, just an A for one. And then two, we would put, in this case, a dot city ID is equal to, and we would need to use CT dot city ID. So basically just finish the on clause.
I think
So-
in the answer, they want the full thing though. It says specify the whole entire query, not just one equals this and two equals that. And the answer below it says write the complete,
Oh, got it. Yep. Okay. Yeah.
which is just as easy to be honest, because you write the query, make sure it
Yeah.
works, then you just copy paste it in there. So
Yep, exactly. Yep. Okay, so question number 2, write a query that returns the title of every film in which an actor with the first name of John appeared. So we did this basically, but we just didn't filter it. So this one should be fairly simple too. This one just takes it up a notch because you got to join 3 tables, which, like I said, we did. And in fact, since we're there, we already did it. We might as well just do it here. So let's take this one. And on these exercises, if you include like extras, because like, for example, this just says to return the title in which an actor with the first name John appeared. I'm not like very stingy. Like, to me, I like context around it. So like if you include the actor's first and last name, that is completely fine with me. So what I'm going to do is I'm going to just change these to a left join for now. And then we're going to say where a dot first name is equal to John. And there we go. So it looks like only one John Savari, but was in a lot of movies. So anyways, that's that one. Question 3, construct a query that returns all addresses that are in the same city. You will need to join the address table to itself, and each row should include 2 different addresses, meaning the same address shouldn't be there. So this is one that I kind of wanted to go through together just because we use what's called a self join. And that's why you will join the address table to itself. Because we want to say, oh, like let's say we're trying to figure out, hey, we're trying to lump these addresses in together so we can assign them to different people, but we want all the addresses within the same city so that we can divvy them out. So what we do, and this one gets a little bit weird just because of what it is, but so let's start with address. So we're going to just select everything from address. There they are. We can see all the addresses. We can see the city IDs. Now, in this case, we don't need to join the city because we don't necessarily care what it is. We just want to lump addresses together. So what I'm going to do is I'm going to give this one an alias. So I'm going to just call it A1. And then what I'm going to do is I'm going to left join. In this case, because it's an inner, like a self join, it doesn't matter if we use left or right necessarily, unless there was addresses without a city. But we know that that's not true. So we're just going to do an inner join against address again, which is kind of weird, but basically we're taking one table and in memory, we're going to create a duplicate of it. It doesn't exist. It's still the same table. We're just going to basically create a copy of it and join it to itself. Now, what we want to do here is on our on clause, we're going to say where the city ID from address 1 is equal to the city ID of address 2. Right, because that gives us basically every city combined with, or every address combined with every other address in that same city. So what I'm going to do is I'm going to do A1.address ID so we can QA this along the way. And A1.address. And then I'm going to do A2.address ID. and A2 dot address. And I'm going to add in city too. So A1 dot city ID and A2 dot city ID. All right. So when we run this, it's going to be a little weird because we'll see the same column names duplicated. So I'm going to add some help here. So I'm going to say, just going to call that A1 ID. A1 address as A1. City is A2 address.
Did not use the AS there.
Yeah, and this time, so this one you have to use it.
Oh, it won't do it otherwise?
No. A2 dot, let's see, ID. 2 dot address as A2 city. All right, so basically these are column aliases, which basically changes our columns up here. So this allows us to pretty much put whatever column name we want here at the top, which is what we will see here in just a second. So now if we run this, there it is. And I'm going to order this because what I really want to do is I want to see it ordered by A1 dot address ID, just so we see the first one first. Now, if we look at this, you'll see this 47 Mysequila Drive matches with this same one, 47 Mysequila Drive. If we look at the instructions, it says each row should include 2 different addresses. So what we need to do is we have the data set we need. We just need to filter it out because we don't want to see the same thing twice, essentially. So what we can do is we can say 2 things. We could add a where clause and say where A1 dot address ID does not equal A2 dot address ID. And that would do it. Or we could change this to just say and, so it's part of the join. So both achieve the same thing, but again, back to efficiency, this way is likely more efficient than the where clause because it's part of the join. So basically we're saying, look, I want to do an inner join against address, but I only want to see the ones where the cities are the same and the address does not equal each other. Now let's change this to a left.
Does this version have where you could do explain and then you can see the total time that it runs
Yes,
to see
it
which way's
does.
faster? Okay.
Yep. It doesn't work in Workbench, I don't believe. Let's try. I guess it does. It's just a little weird. And we talk about explain when we get to indexes, but yeah, it does have it and it'll show you filtered 100 using where because it has the index. Anyways, so anyways, yeah, it's a little weird in Workbench, but yeah, in the command prompt it should be there. But I changed that inner join to a left join so that way we can see all the cities that don't have all the addresses that don't have an address in the same city, essentially. So that's again where kind of knowing like what you want to look for is good. But in this case, I'm just gonna I'll take it either way. It doesn't really matter to me, but let's look at the instructions. What does it say? That are in the same city. So yeah, let's just leave that in inner. We had it. There we go. So those are the addresses that happen to be in the same city. And we did that just by utilizing an inner join. So we do the same thing And that's the one time when aliases are required, is when you do a self join. All right. Write a query that shows all the films starring Joe Swank that have a length between 90 and 120 minutes. This is the same thing we've done before, just with a where clause and all the films. So nothing too crazy. And then question 5 is write a query that shows how many rentals are associated with each of the 2 staff members. So this one is a little bit of a teaser to, I believe, what we cover. Is it next week? Let's look here real quick. Tab. Week 5. Nope, not yet, but a little bit of the teaser. So I'll show you this one because this one has a little bit of aggregation, which we haven't covered yet. So we want to see how many rentals each staff member has. So kind of like a lifetime count of their work, essentially. So I start with staff, select everything from staff. There's our 2 staff members. We have staff ID. And then if I take a look at rental, because that's what we want to count, select everything from rental. Let's look and see. Oh, look, we have a staff ID. So nice and easy. So we can say select, and I want the staff first name, last name. Let's get ID, first name, last name. First name, last name. I always like to include the IDs. Right? And then we're going to say from staff S. So I always like to run them and then kind of build on it. So then from there, we want to left join rental R on S dot staff ID is equal to R dot staff ID. And you'll notice we get a bunch more data. But what we want to do is, instead of having like all the data listed out, and we can see R dot rental ID, so we can see all the individual ones. Instead of seeing each one listed out, we want to summarize it or aggregate it. So we want to see all this rental ID. Instead of it being each one listed out, we want to just count them and condense it down into our staff information. So in this case, we need to perform aggregation. So we need to put an aggregate function here. So I'm going to say count distinct R dot rental ID. And I'm going to give it a column alias as rental count. And basically what this is doing is it's counting unique rental IDs. Technically, rental ID is a primary key, so it should be unique anyways, but I always like to include distinct just in case. So count distinct rental ID, that, and it makes it clear like, oh, we're getting a unique count. Now, if I try to run this, it's going to throw an error. And you'll notice that this error down here, it says an aggregated query without group by. So basically what it's saying is like, hey, look, you're telling me you want to aggregate, but you didn't tell me how. You told me how to count, but you didn't tell me how you wanted it to group by. So in this case, most cases, the group by is pretty easy. You just put whatever columns come before the aggregation. So we're going to say group by, and then just list out those same things and put a semicolon at the end. And now we can see the staff ID of the staff, their first name, their last name, and let's change this to be lifetime rental count. There we go. So we can see that they're both doing pretty well. Just like, 36 different, which is maybe just like one shift, who knows? Now, like I said, because we have 4 minutes left. So first I'll pause there. Does anyone have any questions? Okay. So just to kind of take this one step further, because you asked like what my favorite part of SQL is, and this is where I really start to get interesting. So, in my job, my day job is in the business intelligence realm. So this is really where I spend most of my day, and my headspace is doing this kind of stuff, because we can look and say, hey, here's their lifetime rental count, and we can say, oh, they're pretty neck and neck. But if we take a look at staff, we have this well, I guess we don't have when they were created. We have when they were last updated, but really what would be nice is to see when they were created. So so that way we could take a look. So maybe we won't do this. But it would be nice to be able to say, hey, Mike started here a year before John did, but John is nearly up in the same kind of rental count. So, on a, we could come up with a KPI or a metric such as like, average monthly rentals to see who is actually performing better, essentially, or if we track shifts or something like that. So I guess we won't do it. I was going to hurry and do it for you, but we don't have the data available because they only have when it was last updated.
Is there any way to like shift that to a graph? There's none that I know of, or is that just a different piece of software?
Yeah, just a
So-
different piece of software.
Okay.
Yeah. So typically, like what would happen is, you have like a BI tool, whether that's Power BI or Tableau. Some are like kind of integrated, like you have things like Metabase where it can kind of do 2-in-1, but ultimately you have your query that gathers all the data, and then you graph it on top. You build a graph from the resulting data, kind of like you would in Excel. So Excel would be another tool. Like, we could take this, export it to a CSV, and then, graph it. So for example, if we wanted to trend this, because if we take a look at rental, you'll notice that we have the rental date. So like if we wanted to trend both of these over month, we would simply just have to add r dot, let's say, year of r dot rental date as rental year, and then month of r dot rental date as rental month. And then obviously we need to add those down here. So the one nice thing about MySQL is that I think we can just put rental year and rental month. I can't remember if it allows that or not. Maybe doesn't look like it.
I think so. I think you could also do select distinct up top and not do group by. But maybe not with aggregates. I don't remember.
Yeah, not with aggregates. So in some database systems, it'll respect this alias, so you don't have to like put all the logic back. But in this case, it doesn't look like it. MySQL is the one. I think it's I can't remember.
SQL Assistant allows us to do it.
Or did I just not have a column there? Hold on, we got to try this.
I don't think it allows aliases because it doesn't know it yet or something.
There it goes. I was just missed a column. Okay, so I think it does in MySQL. It does acknowledge the alias. So in the group by. So now we could build a trend, and see like which ones we wanted. So I'm going to take off that sort. So now we could take a look and say, there's our group by, but let's order it by rental year, rental month, and then staff ID. There we go. So now we can see, like, in this case, they both started the same month. In fact, they've both worked the same amount of time, but now we can kind of see it trended. So if we wanted to build this into a graph, now we would have the data to kind of do so. And we will cover group bys in depth in a future week as well. So this one's just a little bit of a bonus just to get those distinct counts, but I think the reason they include it is because they kind of give away the answer right here. So all right, and I think that is the last question on the exercise. So does anyone else have any other questions join related?
For those of us that want to do the final project, are there any things that you think we should start doing now to prep for that?
Yes.
That's in relation to the joins?
So not necessarily in the joins. What I would say, and I think I put this in the announcement, basically up until week, I think it's week 5. So next week, really you should start working on the ERD. So basically that same process we did, but basically just planning out your database. And as soon as you get that done, if you are like unsure about it, feel free to like shoot over like a screenshot of your diagram to me. I'm happy to take a look and give any input. Also, if you need like just like a couple more tables, again, feel free to shoot over what you have. Because I'm pretty good at just being able to like add a couple tables here and there that are easy and not too much work. So
And it needs a minimum of 10 tables. Am I remembering that correctly?
correct. Yep.
I think
10
it's
tables.
12.
It says 12 in the instructions, but
Okay.
I go 10 just because I don't want fluff necessarily, and from my experience, a lot of them have been, there's just
Yeah,
some that just don't need 12, and so
I started doing it. If you want me to show it my screen, I can kind of give an idea of what I came up with.
yeah, that'd be great. Actually, let me make you a presenter real quick. All right, yeah, go
I got,
ahead.
let's see. What's up? What's up? Here we go. Make this smaller.
And I guess as you're getting that, is a
Oh, is it sharing it or no?
not yet. I think you'll hit share and then you'll have to choose a screen or something like that.
Oh, that's, yeah, choose screen. I think that you see
There
it
you go.
now.
Yep, we've got it.
Okay. Yeah, I don't know how to move the stuff out of the way. But right here's my TV. And then hooked to my TV, I have a DVD player, a Blu-ray player. I don't know how to move this stuff. Then I got like, I have subscription services. So you think about like Netflix, Hulu, stuff like that. So this was a many to many relationship. So then I had this helper table. So, I have Hulu on this TV, but Hulu could be on a TV downstairs, Netflix, all those sort of things. Sound system. So this TV has a sound system and my sound system has speakers. So one to many relationship here. And then TV can have multiple gaming consoles, so it might have a PS5 and a Xbox 360. So we have a helper table, and then a gaming console could have gaming components like controllers and power cords and headsets and whatever. And a
Yep.
gaming console would also have like video games, right? A lot of different video games. And then over here I have streaming devices. So your TV might have like an Apple TV or a Roku or Amazon Fire or whatever. So that's good. I was just kind of thinking like TV is kind of the main thing. And then what's hooked to your TV, right? Breaking it down. And then
Yep.
surround sound, what's hooked to your surround sound, speakers and stuff like that.
Yeah,
So
no, that makes sense.
that's my general idea there. The one thing that I was getting really thrown off and I took it back out was internet. Because it's like internet's hooked to everything and it started to make my joints super crazy. So I was like, I might not even want to touch that one.
Yep. If you wanted to like, because like this would work great, and a lot of it just depends on like the end use case. So, like I don't really know like what you plan on having like the UI like necessarily, which obviously like is the biggest factor in like how you design your database is kind of like the usability, business logic on the other end. One thing you could do is you could basically consolidate a lot of these tables down into like, so you could have basically have a device table that would include all of your TVs, your DVD players, your consoles, and your sound systems. And then you could have like a connection table that basically is device 1, device 2, and then like some additional information. So for example, device 1 could be your TV, and device 2 could be your gaming console. So like if we were going to flesh this out, let's say you have one TV that's like your Samsung, let's just say TV ID 1 or device ID 1, and then your gaming console is device ID 2. It's your Xbox, right? And then in that connection table, you could also have like how it's connected. So HDMI, DisplayPort, then you could have like I don't know what the term is, but like a cable type table that has like HDMI, Ethernet, DisplayPort, all those kinds of things.
Yeah, I thought
Anyways.
about that a little bit. To be perfectly honest, the reason I didn't, I was like, I don't know if I can get enough tables that way because I'd be consolidating it.
Yep. Yeah. Which is the one thing, because basically you go from however many tables these are to like, 3. But,
Right.
but yeah. But like this one makes sense because like if you want to keep it like really separated, like this works just as well too. Because maybe maybe there's certain things that have, like a gaming console has a lot of different characteristics than a sound system, so to speak. So to me, like when I try to combine things, a lot of it's like, what do they have in common? So like, your Blu-ray player to DVD player.
Yeah, I definitely thought about those are about the same, right?
Those are about the same. Now obviously, like I said, it just depends on like your different stuff. But the reason why it's nice to consolidate, because like let's say we were just gonna like kind of build like and this is where I say it depends. Like, and so let's say we were just gonna build a wiki, which I know this isn't like what yours is, but like let's say we wanted just to build a wiki of like all the different like devices out there. Versus like if I'm building a UI that lets people like filter and browse essentially, like I can say browse by brand, right? And let's say I want to browse by brand. Instead of having to write many queries that say like, oh, select everything from Blu-ray player if they want to see the Blu-rays, or select everything from DVD players if they want to see the DVD players, and then try to like union them. Like you can see how like basically what the user does is going to like change a lot of like the queries, versus like if they're just wanting to browse, if it's all in one consolidated table, I can say, hey, I want to see like what's all the Samsung devices, and I have a list of all TVs. Oh, I want to filter down just so I can see the Samsung's Blu-ray players. It's all one query, just with additional where clauses, because then we can say, oh, where device type equals Blu-ray, where brand equals Samsung, and instead of having to, because we can add where clauses pretty easy dynamically, but to change the from clause is more involved, if that makes sense.
Right. Yeah, that makes sense. And it's kind of the same thing on whether it's wireless or not, right? Because I got wireless speakers or maybe wired speakers. I got wireless controllers or not wireless controllers. You know what I mean? So kind of the same idea that you're talking about.
Yeah.
So,
but yeah, no, I think like as far as this goes, I think it's great. Like it'll work. And really like that's like the ultimate thing, because like really these are you guys' creations, and what I say every term is like, because one thing that I like about databases is there's a lot of different ways to skin the cat, and it all just depends on what the outcome is. And I think that's why, because I always have students like, why do we have to build a wireframe? If we're not going to actually build the application, why do we have to build a wireframe? And really it's like because of this. Well, because the way we design the database has real implications for the user interface and vice versa. And so, it's really difficult because we got to think through the whole process. But, the database that we design here don't have to be perfect. It's really just like a matter of like in that case, like, oh, maybe through this process we learned that like, oh wow, that would be difficult. That's fine. You don't need to remake your database, halfway through the course. It in the PowerPoint, and I think I may have already touched on this, or we will later. When we go to make the PowerPoint, one of the last slides that I always encourage people to include is like, what would you have done different? What did you learn? What would you have done different if you had to start over? And that's basically your chance to kind of like say like, oh, what would I change? What would I do different? Yada yada. So yeah, it doesn't have to be perfect, because like I don't know where the end goal is for this one. It looks like it's designed perfectly though, like as far as the relationships and everything. So yeah, it looks great.
Yeah, I kind of had to Google the interdependent or dependent, whether it's the dotted line or not, right?
Yeah.
So I was like, I think it's this one, but I don't know. We'll learn more about it. Like,
Yeah, and I usually and I think I covered this when I did mine, is I don't use the UI to build the relationships. I use the UI, but I don't draw the line. I with the tool here, I do it manually in the tables.
yeah.
And it usually builds the dotted lines for me, but I don't know if it matters too much for what we're doing here. So yeah, perfect. Awesome.
All right, cool.
Yeah, I appreciate you sharing. That's nice for everyone to see. But yeah, just to circle back, this week, basically this week and next, you should be working on that ERD, getting it to a place just like that where it's all ready. Because basically next week, what we're going to do is I'm going to show you how to take that ERD and MySQL Workbench, and we're going to generate code for it, and we're going to set up our environment so that we can very quickly iterate on it. Basically, we can build scripts that will erase it all and then recreate it. Which sounds scary. It's not, but trust me, it saves a ton of time. So you don't have to like do this thing every time you make little tweaks, because the reality is we're probably going to make little tweaks as you start to insert data. It always happens. Even for myself, I always like, oh, I forgot this, or, oh, that's not going to work. So I got to go make some changes to the table. It's a lot easier this way. So, anyways, I'll show you how to do that. So yeah, so if you want to start kind of working on it this week, that way you'll be up to speed, and then next week you can kind of polish it off and hopefully follow along with what we do there. And then after that, we'll start inserting data and that kind of stuff. So yeah, awesome, great question. Glad you brought that up, and thanks for sharing, Waylon.
Yeah, you're welcome.
All right. Any other questions before we dive out of here? All right. Cool. Well, appreciate you all being here. As always, the recording will be posted later if you want to circle back to it. But definitely appreciate you being here. I know there's not very many of us, so just know that there's a lot of other students that are benefiting from you guys' questions and participation. So glad you're here, because it's always not fun just to kind of record a video to nothing. So appreciate you guys being here, and the rest of the class should thank you as well.
All right, thank you.
Yep,
Thank
thanks.
you.
And you guys all have a great week, and let me know if something comes up.
Will do.
All right. Yep, thank you.